I'd like to say a few more things about the periodic table. So the periodic table, like we saw in the previous video that I made, as you go from left to right, it's increasing in what we call atomic number, which is the number of protons. You get to the end of a row, and then you skip down to the next row, increasing number of protons. And as it turns out, where you kind of break that row and kind of wrap back around, that was discovered by Dmitri Mendeleev, how to assemble, where to wrap, and make our how to assemble our periodic table. And it was done so that according to the what we say the periodic nature of the elements. So as it turns out, we'll talk more about this, but if you look down a column of elements on the periodic table as it's assembled, they have similar chemical properties, and we'll talk about why that is here soon. It's very similar, I think, to, and I'll kind of put all this up here now, it's very similar to a calendar. So if I was going to look at a calendar, the top of my calendar has Sundays, Mondays, Tuesdays, Wednesdays, Thursdays, Fridays, and Saturdays. Now, each one of these days, you probably have kind of a different feelings. Like, for instance, I'll skip over to Fridays and Saturdays. You might have extreme happiness if you're a student because you don't have classes to go to. So happy, 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 happy. And then if you're maybe most students about Sunday, especially Sunday night, you're going, not quite so sure. Maybe I should have studied a little bit more during my weekend. And then you get to Mondays and you're like, oh, grr, Mondays. Regardless if you're a student or out there in the real world, Mondays can be kind of rough. And then Tuesdays, you're like, oh, I think I can do this. Okay, and things like that. But my point is that each kind of, all of the Sundays have kind of a similar feeling. Mondays have a similar feeling. Now, it's not exact, and of course the weekend is wonderful, right? So, but if I were to kind of fill in days, or fill in a week, what, it would go 1, 2, 3, 4, 5, 7 days a week, 6, 7, and then we'd start all over again. And by where I kind of make my breaking point and wrap it back around, okay, that's where I then get this, because of the periodic nature of the month, that's why, and where I break it, I get these guys lining up. And that's exactly what they did, what Mendeleev did with the periodic table. So one of the things I want you to know about a periodic table is this idea that, So as these builds go, each one of these yellow things, of course, is marking a column. And the column actually are called groups. And groups then, like I said, kind of like days of the month, or days of the week, they have similar chemical properties. All of these have, as they're being marked, have similar chemical properties within a group. I want to mention something. We'll be referring to the name of the group. And for instance, if we just kind of pick on these guys right here, can you see where this particular periodic table actually has kind of two designations? It has the number designation, and then what I oftentimes refer to actually is the second thing right there. 1 and 1A are both talking about this particular group. Oh, while I'm at it, if you want to put group, sometimes these are called families of elements within the same column. Let's skip over here with regard to column designation. Go over here to fluorine, chlorine, bromine, iodine, and astatine. So notice that we have 17 and 17A, 17 and 7A, and you're going to hear me kind of refer to it as group 7A, just so that we're all kind of on the same page there. But my point is that within a column of elements, they have similar chemical properties. Then, of course, I'll kind of go across. This yellow bar that you're seeing going across, that is what we call the periods. So that would be like the days in 1 week. So that's a period, period, period. And for your exam that you're going to have in this unit, you're going to get a periodic table, and there's going to be numbers over here, so let me go ahead and show you. This is period 1, period 2, 3, 4, And most periodic tables show the period, 5, 6, 7, okay? And so, for instance, if I were to ask you for manganese, what period is it in? Hopefully you would say it's in period number 4, okay? But it has properties most similar to these chemicals, or these elements, okay?